Welcome back. Question 10. If this is the first time to this channel, please make sure you click on the subscribe button and the notifications bell to be able to watch all our videos for free and to be notified when new content is uploaded. Question 10 reads, sub 1, given that 2y is equal to x squared plus sine y, show that cos y minus 2 d squared y dx squared minus sine y dy dx all squared plus 2 equals 0. Sub 2, a function h is defined as follows. On the set of real numbers excluding negative 2 as h of x equals x over x plus 2. Sketch the curve of y equals h of x. If you are interested in having a complete solutions in PDF form of all these past years from 2015-2023 or 2011-2023, please use the link below to contact us. Leave your comments as you watch these videos and don't forget to share to not less than 10 WhatsApp groups if you enjoy what we are doing. If you cannot do that, it means you don't enjoy what we are doing and you're not helping the channel to grow, because the more content we see, the more subscribers we see, the more likes, the more content we create. But without this, we will not have time to be doing that and will not be motivating our team. Thank you, because now you are doing that right now. You are clicking on the subscription button and the notifications bell. Now, let's hit this question big time. So, for the first part of this question, they say we should show that cos y minus 2 d squared y on this x squared minus sine y dy dx squared plus 2 equals 0. Okay, so here this is what we have. We first of all differentiate. So when we differentiate 2y, we are going to have 2 dy dx. Okay, we now is equal to, we differentiate x squared, we have 2x plus, we now differentiate sine y. When you differentiate sine y, you have cos y, but since the function of y we talk about, we now add cos y dy dx. So this is the first derivative. According to this question, okay, according to this question, we are supposed to end at d squared y dx squared. So we are going to differentiate again. So differentiate this again, we are going to have 2 d squared y dx squared is equal to 2 plus cos. Now these are two, this is a product of functions here now. Okay, we're going to apply the products rule. So we keep cos y constant. We differentiate dy dx, we are going to have d squared y dx squared. Now plus, we now keep dy dx constant, and we differentiate cos y. When we differentiate cos y, we are going to have negative sine y dy dx. Now that dy dx times the first dy dx that was there before is going to give us dy dx, all of that squared. Okay, so when we now simplify it, we can rearrange it to have cos y, because this is dy dx, right? D squared y dx squared. So you can have cos y, okay, minus 2 d squared y dx squared minus sine y dy dx all squared plus 2 equals 0. So you can rearrange to have that. And this is it for this first part. The second part now is to sketch the curve of the function h of x equals x over x plus 2. We have so many videos on curve sketching. Please just check our channel, you see many of them. Even for logarithmic exponential functions, rational functions with a constant numerator, rational functions with quadratic denominators, and so on. You have many of these functions that we have done, and this is an example here. So as required for the previous part. Sub 2. So for this, the first thing is to get the domain. For the domain of this function, the denominator must not be equal to 0 because it's a rational function. So x plus 2 should not be equal to 0 and x should not be equal to negative 2. Therefore, the domain of the function is from negative infinity to negative 2 and from negative 2 to positive infinity. We have given the domain in interval form so that we can find all the limits easily. You can equally see that there are 4 bounds. So from negative infinity to negative 2 from below, then from negative 2 from above to positive infinity. So after the domain, the next thing are the limits. For this function of x tends to plus or minus infinity, we just take highest divided by highest, okay? That just give us x over x equal to 1. So the limit is equal to 1, okay? Just think about 1 billion over 1 billion. Because this plus 2 is not going to affect it in any way, really. It's negligible. So that's just going to give us 1. So we have taken these two limits at the same time because the values are the same, okay? Now, you need the limit as x tends to negative 2 from below. As x tends to negative 2 from below, we take a number slightly less than negative 2. like 1.9 and we fit here. So 1.9 we put in this function is going to be, sorry, we are talking about negative 2 from below. Sorry, so let's take negative 3, okay? We could take negative 2.1. So negative 3, all over negative 3 plus 2. The numerator is negative, the denominator is negative. We already know that at x equals negative 2, yes, at x equals negative 2, the limit is going to be infinity. So we just want to test this now to get the sign. So from here, we see that as x tends to negative 2 from below, we are going to have positive infinity. And as x tends to negative 2 from above, we have, take a number slightly greater than negative 2, we have negative 1. So negative 1 over negative 1 plus 2. Numerator is a negative, denominator is positive. So this gives us a limit of negative infinity. Next, we need to look for the asymptotes. We can see the vertical asymptote from the domain of definition. Those x values. So x equal to negative 2 is the equation of the vertical asymptote. And for the horizontal asymptote, we can see it in the limit, the numerical values in the limit. So y equal to 1 is the equation of the horizontal asymptote. When a curve has a vertical and a horizontal asymptote, then the center is given by vertical asymptote, comma, horizontal asymptote. So that's what we call the center of what? The center of symmetry. Next thing, we need the gradient function. Or before that, you can get the intercept. So these are the values where the curve cuts the coordinate axis. As x, when x equals 0, in this particular function, y equals 0. So the intercept is just the point 0, 0. Next, the gradient function. So our dy dx or g prime will be equal to, since the rational function, keep the bottom constant, differentiate the top 1, minus the top constant, differentiate the bottom, all down the bottom squared. When you simplify, you are going to have 2 over x minus 1 squared. Okay? So you're going to have 2 all over x minus minus 1 squared, which is strictly what? Strictly greater than 0. So it means that this curve is strictly increasing on the set of real numbers on R. Now we need the table of variations. So the domain is here from negative infinity to 1, sorry, to negative 2, then to positive infinity. Okay? Then our f prime, we're going to check our f prime. So our f prime is always positive. Okay? So this is a vertical asymptote. Vertical asymptote. So with the table of variations, we know that the function is strictly increasing, right? So this for the f prime of x is positive, and here is also positive. This thick line indicates that x equals negative 2 is the equation of what? Of the asymptote, right? Which asymptote? The vertical asymptote. And since f prime is positive, means that this thing will be pointing upwards. It increases from a certain number. The limit as x tends to negative infinity, we have 1, increases from 1 to, as x tends to 1 from below, sorry, negative 2 from below, what did we have? Negative 2 from below is positive infinity, so it increases from 1 to positive infinity, okay? And as x tends to 1 from above, so, sorry, negative 2 from above, we have negative infinity, and as x tends to a plus infinity, it was 1. So that's a table of variation. Now let's sketch it. So now for us to sketch, we have the following. So this is how the curve will now look like. We just take all those information and then we put here. This is a vertical asymptote, x equals negative 2. Horizontal asymptote occurs at x equals y equals 1. Then it is increasing as follows. We have an intercept here, right, at 0, 0. So the curve increases like that and like that. So this is it about this curve, okay? And we have many other things concerning this curve which you can check from our channel. Okay, remarks. So when the degree of the numerator and denominator are the same, there is a horizontal asymptote A. Okay, and this curve will have a point of symmetry at the point, let me say here in this case we have negative 2, 1, and has 4 bounds. Thank you so much for watching. If you need a complete solution to these questions, please contact us using the link below. If you need the other 9 questions, click on the links below or the playlist and you equally have them. Do not leave without subscribing to this channel. Okay? When you subscribe, click on the notifications so that you get the information and you are free to watch all our videos. Subscription is free. We only need chemistry past papers, just paper 3. Some students sacrifice and teachers for you to have this one. And now some students are in difficulty and they're requesting for that from us. So please, if you have them, send. Don't tell us that you ask students. You have students who are doing science. Collect from them, snap and send, or send in PDF form. Thank you so much, and may God bless you. Don't forget to watch the paper 3 of 2023 and all the other videos online. Leave your comments, and we love you all. Ciao.